This is my third video in my module on the dot product of vectors, and in this video we're going to focus on the relationship between the angle that is formed between two vectors that are graphed in standard position and the dot product of those two vectors. Okay, so let's go ahead and start with a few basics here. We say if theta is our angle, then, or that is, if we were to have two vectors and sketch them in standard position, that is, okay, then the angle that's formed between these two vectors, theta, is given by this equation here. So we say the cosine of that angle would be equal to the dot product of the two vectors that we're multiplying, or that we've got graphed, over the magnitude of the two vectors in a product in the basement. So essentially, we could use this to solve for theta if we need to, and we will. So we say the angle between two vectors, and we say is some angle theta between 0 and 180 degrees. And we'll talk about why it's between 0 and 180 here in a minute, but the angle theta between the respective standard position vectors is given by this. Here we can solve for theta. So all by finding a dot product. That's kind of nice. We're going to start by finding the angle between these two vectors here, and then we'll kind of show this with a computer-aided graphing device. But we say, let's have two vectors u and v. We say u is 0, 7, so we say 0 left and right, 1, 2, 3, 4, 5, 6, 7 up. So we say here's our vector u in standard position, graph starting at the origin, and then we say also 5, 2, so right 1, 2, 3, 4, 5, up 2 in standard position, so we're starting at the origin here. The reason why, first of all, and I do want to bring this up, we say the angle between these two vectors, we say it's some angle between 0 and pi, and so essentially we're always going to go for this shorter of the two angles here. We'll never go around the outside like this, okay? It's always between 0 and 180. Also, we notice here that the angle theta is acute. I just wanted to bring this up here, acute, because that'll come into play here in a minute. So let's say we want to find this angle. Well, what we know is this. We say the cosine of the angle between these two is equal to the dot product of these two vectors over the magnitude of these two vectors in a product. So we'd say the magnitude of this times the magnitude of v. So let's go ahead and find a few things first. Let's start with the easy part, which is u dot v. So now we say 0 times 5 here, multiplying the x components. We say u dot v would be the same thing as 0 plus, and we say 7 times 2 is 14. So we'd say 14 on top, okay, is what we get there. On the bottom, though, we have to find the magnitudes of u and v respectively. So we could go ahead and do this on our picture over here. We say, oh, well, we could draw a triangle. We say, right, 5 up 2, and use Pythagoras to solve for this. And we could say, well, definitely this one here is obviously 7 units in length, is the magnitude of u at least. So we'd say this is 7. But we could also solve for these using a formula other than, Pythagoras, which is Pythagoras here we are using. But we say the magnitude of u, recall that the magnitude of u is equal to this. We say it's the square root of u1 squared plus u2 squared, where this is basically the magnitude of u1 comma u2. So basically it's the square root of the x and y components squared and summed. So we say, all right, well, I've got 0 squared plus 7 squared is the square root of 49 here. So we say the absolute value of, or the length or modulus of this vector is the square root of 0 plus 49 is square root of 49 is 7. And we can do the same thing here with vector v. We say, all right, well, the modulus of vector v here, we'd say is the square root of 5 squared plus 2 squared is the square root of 25 plus 4 square root of 29. Okay, so we get the root 29 here, so root 29. So we could say, all right, well, the cosine of all this, and sorry for the handwriting here, we say is 14 over 7 root 29. And so this is not a horrible thing to get here. Essentially, if we take it up here for a second, we say cosine of this equals 14. I'll write a little bit more cleanly, 7 root 29. What we're going to do is we're just going to go ahead and provide this as a decimal, and then we're going to take the r cosine of both sides, we say, or the inverse cosine of both sides. So we take the inverse cosine on the left and the right. So we say theta is approximately equal to, here's where we need our calculators, okay? So we say, all right, well, let's get this rocking here. We say 14 divided by 7 root 29. What I'm going to do is I'm going to do 29, I'll take the square root of that, times 7, and that's my value in the denominator. I'm going to divide it by 14, but then I'll reciprocate it. I do this differently on a different calculator, but we say divide by 14, and then I'll just flip this fraction over. But we get let's see, 37,139, so 37,139 is the value of what was in there, and we need to take the cosine inverse of this. So we get cosine inverse of that, and I wonder if I could do this. We say memory store. I'll head over to my cosine inverse, which is cosine negative 1 of that. We get about 68.19 degrees, so about 68.2 degrees, so 68.2 degrees. Does this look, valid? Well, I don't know. I mean, looking at the same angle that I'm looking at here, 68.2 degrees seems extremely valid. So essentially, if you have two vectors, you can always find the angle between them by doing the arc cosine or the cosine inverse of this value right here on the right. So a few things I want to say about this before we depart from this video, starting with this. The expression that we just worked with here that said that the cosine of the angle between the two vectors is equal to their dot product over the product of their magnitudes. We could take both sides of this equation times this bottom quantity here, magnitude of u times magnitude of v. And what that would do is cancel it out on the right side here. And put it on the left. Now that would mean cosine of theta is being taken times magnitude of u times magnitude of v, and we can see that here, and I moved over to the right, and that equals u dot v. But the thing I want to say about this is this: remember, magnitudes, those are lengths, and lengths are never negative. So we could say that the magnitude of u and the magnitude of v I write here must always be non-negative. Okay. So basically, the conclusion we can arrive at is this: well, if the left side of this equation equals the right side, then essentially this u dot v has to have the same sign, 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 as the cosine of theta. Now this is pretty profound, because what this means is if I know the value of u dot v, it relates to cosine of theta, and we already know some things about the cosine of theta, at least between 0 and 180 degrees. So, going ahead and sketching out what we know about this, at least on the unit circle, we could draw in 0 to 180. We say here's 0. Here's pi, and this represents the angle between two vectors. We'd say, well, here's one vector, we could say is be going in this direction here. But basically, we know about cosine between 0 and 180. All students, we know cosine is positive for all values between 0 and pi halves, and it's negative for all values between pi halves and pi. Okay. Also on the unit circle, we know a couple of values of cosine right off the bat. We could say, well, the radius of the unit circle is 1, so we say this is 1, 0, this is 0, comma 1, and this is negative 1, comma 0, where our cosine values are these x values right here. But essentially, here's the profound thing about dot products, and we'll kind of draw the connection here. Notice we have 5 arrangements of vectors up here, but when two vectors are going in the same direction, okay, that'd be like this case over here. What we're saying is this: the angle between them would be 0. I mean, if I had a vector going to the right here and another vector going to the right there, the angle between them essentially right there would be 0. And if the angle between them is 0, then we'd say, well, then the cosine of this is actually going to come out to be 1. Okay, so basically what I can tell us is if the u dot v equals this guy here exactly, then the cosine must be 1. If the cosine's 1, then they're heading in the same direction. Okay, whereas if cosine's negative 1, I've got two vectors that are heading in the exact opposite direction. That'd be 180. And if the cosine is 0, we'd say, okay, well, then the angle between these two vectors must be 90. Okay, so these are orthogonal vectors. Okay, so getting these right out of the way, right off the bat, if the cosine of the two vectors is 1, they're heading in the same direction. If it's negative 1, they're heading in opposite directions. And if it's 0, they're orthogonal or 90 degrees to one another. But here's a pretty cool fact also. If the angle between them is acute, so that's somewhere here, my vector is in the first quadrant forming an angle with this vector here going in a 0 degree or 0 radian direction. If it's acute, then what I can tell you is that the cosine of this is going to be positive. So essentially, here's what I want to get at. If the dot product of two vectors is positive, then the angle between them is acute. And that's exactly what this says here. If the dot product or the cosine, since they have the same signs anyways, so to say that the cosines between 0 and 1 is like saying the dot product between 0 and 1 kind of thing, or at least it's positive. So a positive dot product is acute angle. We say positive dot prod if the angle between them is acute. If the angle between them is obtuse, we say a negative dot product is in order. Okay, so let's go ahead and take a look at definition of orthogonal vectors really quickly, and then we'll bury this here. But I do want to talk about this orthogonal case. Since the cosine would be 0 to 90 degree angles, and two vectors would be orthogonal if the cosine is 0. So essentially, we want to know, are these two vectors orthogonal? Well, what we need to know is basically is the u dot v between them, is it equal to 0? Because if cosine was 0, then the whole right would be 0 in this equation. If the whole right is 0, then u dot v is 0. In other words, this is a fancy way of saying two vectors. are orthogonal, are orthogonal, or orthogonal if and only if their dot products equal 0. So here's what we're going to do. We're going to take u dot v, which is negative 16 comma 15, in a dot product with 5 comma 2. So vector, dot product vector, we should get a scalar. So we say 6 times negative, or negative 6 times 5 is negative 30, plus 2 15s, that would be a positive 30, so we get 0. So, and we could definitely show this by sketching them really quickly. I mean, to go left 16, left 6 and up 15, that'd be something, you know, like along the lines of this. Left 2 up 5 would be the same thing. And then right 5 up 2, you know, that'd be like right about here. We say here's our vector. It seems that these would have a whopping right angle between them. Okay, so basically, if the dot product of two vectors is 0, they are orthogonal. That's what we get from this video. Also, if the dot product between two vectors is positive, they have an acute angle between them, and if it's negative, okay, then they have an obtuse angle between them. Cheers.